So in this part of our lecture, we'll be learning about some basics of probability theories. But first, we may ask questions that why to learn probability theories. In our last week, we introduced you to some machine learning and non-ML problems. So if we ask you to find the maximum from a given list of numbers, you may quickly figure out that this is a non-machine learning task because the answer is deterministic, okay, right? What are some other similar examples? What was the lowest recorded temperature in Grand Rapids over the past 20 years? Again, this is a deterministic problem. On the other side of the coin, if we ask you, will it rain tomorrow? What are the chances? So this is a non-deterministic problem, and here some machine learning tasks are involved. Another example is who is going to win the next NFL games between Texans versus Ravens. So again, there is no deterministic answer for this. So here we have some uncertainty involved, okay? And these are actually non-deterministic, okay? Another example is a translation task. So if we ask that, can you translate the following text from English to French? Again, there is no one-to-one solution for this. So to identify the difference between machine learning and non-AI tasks, regular or standard programs are deterministic, whereas AI or ML programs are non-deterministic, lives with uncertainty, okay? So how do we measure uncertainty? The mathematical theories that does that is the probability theory, and we all learned in our high school math. So again, here we are just trying to connect why we would need probability theories. Let's try to explain the concept from another perspective. So if we ask you that, can you fill in the gap? I am very. Let's think a little bit. So you may have different answers like I'm very happy, or I'm very confused, I'm very excited, I'm very tired. So here you can see that the domain is quite open, right? But if I give you some more context, for example, it's already 7 p.m. I have been working since early morning. I am very, then blank. The answer is going to be very precise. I guess that most of you are thinking tired. But again, here we cannot be 100% sure that tired will be the only answer, but we can be sure that the domain of uncertainty actually reduced from previous example to the next one, okay? So again, additional context can help us reduce uncertainty, but the whole idea is when we talk about AI problems or machine learning problems, the probability theories will always come, okay? And that's why we will need to review the concept of probability theories, okay? As a part of our first assignment, we will be trying to solve a probabilistic problem similar to what we will discuss as a toy problem. So imagine that you are given some orange and green balls in two boxes. One of those are red and the other one is blue, okay? And we tied your eyes and asked you to pick a ball, and it turned out to be an orange ball, okay? So your job is to find out the probability that the ball you picked up is actually from the red box, okay? At first, it might seem a very trivial problem, but I ask you guys to think a little bit, because if you can solve by yourself, you can grasp a lot of concepts from this course quite easily or quickly. Okay, so again, the problem is you are given some orange and green balls in two boxes. One is red, the other one is blue. We tied your eyes, you picked up a ball and it turned out to be a orange ball. You have to find out the probability that the ball came from this red box. Okay, let's try it.